Good morning, everybody. Welcome to the Wales-Darby Fujitsu training series. Today, you got myself, Rick Koester. We got Rob Clemens, the man behind the scenes. He will be answering any questions you guys might have today. If you look in your dashboard, you should have a questions section where we can throw in some questions, as well as a handout section. Today, we provided you with a couple things in there. We'll go over them in a second. We're going to go over today the multi-positional air handler you see here to my right. New product. About 2-3 months old now. So we're gonna Mr. Presenter mode in the background now.
Oh, sorry. Yeah. Good to go.
Little stumbles begin. There we go. So you guys should see there. So today we're gonna cover the product line itself and some comparisons within our competition and the different models that we are offering. We have our components and accessories. We're gonna go through basic installation practices and connection points, and then we'll finish up today with questions. Don't hold the questions off to the end. You know, throw them out throughout. Like I said, we got Rob Clemens here in the background, so we'll go through all of those as we go. Handouts, like I said, we got our Wales-Darby line sheet. If you're not familiar with all the products that we do represent, we got a nice sheet there to show you. On the back side, 2-pager, we have our contact info there, so you will find the contractor services team that mentions our, that has our whole crew from New Jersey and New York, Rob Clemens, Jim DePalma, John Resso, and Mr. Anthony Tosti. You'll also find the 2021 full line catalog. That's something new, not in print yet, coming shortly. And just keep in mind, this training itself is not the basis of installation. We always want to revert back to our installation and design and technical manuals. So the 4 models you're going to find in the multi-positional lineup are going to be the 2, 2.5, 3, and 4 ton. This is the 2.5 ton we're going to model off today. We're going to show off some of the components inside there in a few. But let's start with some comparisons. So if you're familiar with multi-positional air handlers, you've seen them in the past. It's nothing new, right? But for Fujitsu, it's a big deal, right? So looking at the 2 of them, they look identical, but really there's not many similarities once we get into the machine itself. So looking at the air handler itself, the main difference in the system from our mini split system to our traditional air handlers or traditional split systems, we have an inverter DC compressor compared to an AC scroll compressor, loud and noisy. Our metering device is now in our air handler. It is not, I'm sorry, in our outdoor unit, not in the air handler like a TXV in a traditional system. Variable speed fan motors, we have them, both units have variable DC fan motors. ECM motors you might find in the blower compartment of a traditional system. Very rarely will we see that in a condenser itself. Some of the high efficiency units, we'll see some ECM motors, but not likely. One of the big differences is obviously like mini splits, we power our indoor unit from the outdoors. So there is no separate breaker. We have 2 breakers for a traditional system, maybe 3 if we're using an electric strip heater. Ours, we have 1. If we use an electric strip, you're going to find that second breaker. The only similarities, like I just mentioned, electric strip heaters, that's really it. Besides cabinet dimensions, everything else is a little bit different. If you're not familiar with multi-positional air handlers, really it's difference in airflow, upflow, downflow, horizontal left and right. We have great operation range down to -5 degrees in both cooling and heating. Features, we're going to go through these. I'm not going to go through all of them on the sheet here. We're going to go through them all individually, but some great features throughout. If you're looking for any of the manuals from installation, operation, design and technical, service manuals, everything that we have that you're used to already, we're going to find all of this on a portal as well as on Zendesk. So multiple resources here for you guys to get all that information you need. One little hiccup. Wait for the slide.
Try it again.
There we go. So nomenclature is really good to know, especially when we get into technical aspects. If we got to call tech support or Wales-Darby, your distributor, TSA, we need to know all the model number, all the letters and numbers that make up a model number. So we've had some changes over the last couple months. Back when we went from ASUGs and AOUGs, the multi-positional is now an AMUG, followed by the capacity, and then our LMAS. So just get familiar with that. Anytime we're calling for tech support, questions, anything in particular, we need to know all of the letters and numbers. This should be in our rear view by now, but it's worth noting. Early versions of the RGLX condenser on the smaller units they were not compatible with our multi-positional air handler. You'll notice anything coming out of the Fujitsu factory is going to have a sticker on it. If you're good at remembering serial numbers, anything new is going to start with an E. Anything older is going to start with a U. If you come across something that starts with a U, you should have seen the sticker on the box way before that point, but it's worth knowing. When we look at the actual footprint of the system compared to some of our competition, we are smaller all across the board, from our smallest units, our 2 and our 2.5 ton unit. When we get into that 3 and 4 ton range, it's even more noticeable because we stay with that single fan condenser compared to our competition with a dual fan setup. So a big difference if we're trying to hide this under a windowsill or something like that. Footprint, I think it's even more, obvious when we get into comparisons of traditional systems. Our footprint is really, really small compared to what they're offering all across the range, all across the product range there. Sound is also another big one for us. On our worst day, we're 55 decibels, right? Our competition in the traditional split systems, they're going to start above us at 58 decibels and go even higher up to 70, 71 decibels. So if we are, for some people that might not be a problem, noise, but if you're installing in a village or somewhere where there is noise ordinances and stuff like that, this might be pretty important to you. And how do we keep this quiet? Really, the big difference, well, why we're quiet, is that compressor's sealed, right? That compressor's behind the cabinet door. We have this insulated acoustic liner wrapped around our compressor. Compared to our traditional system, right, where we have that scroll compressor underneath the fan, it's really just projecting all that noise straight up and out of the unit. So a little bit different there than from us. So that's where that noise is going to come from. Just goes directly out the top. So when we get into efficiency, very high SEER ratings, pretty good SEER ratings, I should say, 19 to 17 from 2 to 4 tons. HSPF is the real number that you really want to pay attention to. And when we go, towards our competition here, you can see on a smaller range there, yes, our competition might have a little higher SEER rating, right? So not a big difference here. You'll notice as we get larger here, 4 ton, some of our competition doesn't even have a model to compare against. But when we get into the HSPF, this is where it becomes a little bit more, advantageous to us, is we're above that 10 HSPF mark. And if you're big into rebates and utility rebates, stuff like that, that seems to be that cutoff, right? So anything under 10 HSPF might not qualify depending on the region you're in. So pay attention to that for rebates. Again, some of our competition doesn't have a model to compete with, but if you notice, all of their equipment is really under that 10 HSPF, so they might not even qualify for a rebate. Heating operation range, -5 degrees. This is not an H model, right? Extra low temperature heating models go down to -15 degrees. We start at -5 with this one, so still some great heat. And if we look in the design and technical manual, this is where we want to size all of our equipment from. We're looking at this here at -5 degrees on a 72 degree indoor temp. We're producing about 28,440 BTUs. That's pretty good heat. This is a 3 ton model. This is the 36, right? So remember that 28,440 in a little bit. I'm gonna show you a little something there when we get into line sets as well and capacities. So -5 degrees, we do not shut down when we hit that rated -5 temperature. We always run below that temperature. We might derate a little bit, but we're still gonna operate all the way down to -10, 15 and beyond. So we're gonna cover some of the components and some of the new accessories that come, that we can hook up to this board or maybe some other areas of the unit. If we're looking at the air handler itself now, we have some new changes. Well, this has stayed the same from our traditional. So this is our electric heater kit. This is that plate's going to come off. We have a kit we'll look at in a little bit that's going to go in there. Our remote controls and our maybe a condensate pump we want to hook up. We have terminals up there as well. Control board in the center, right in front of our blower. So we got our blower and our fan motor behind here, and then our aluminum coil down below. So drain pans and all that. We'll get into a little bit more detail as we get moving forward. So here's the aluminum coil. Lanced aluminum fins improves the heat transfer of the coil itself. It is all aluminum tubing, so a little bit better, stands up a little bit more better to some of the maybe stuff that's in the air that's coming across the coil, right? So it resists some kind of corrosion, whatever that may be. It is a continuous adjusting fan, so it is a X13 fan in here. So as our filter starts to clog up, that fan will actually ramp itself up to 1 inch of static. So pretty high compared to some of the equipment. If you've installed some of our air handlers before, they're very low. We had our mid statics that went up to 0.8. Our multi-positional now goes up to 1 inch of static pressure. So pretty good performance there. The cabinet itself in a whole is ASHRAE rated up to 2%, right? So 2%, less than 2% cabinet air leakage, which is really good. And we'll show you once we get into some of the installation practices how we can maybe tighten it up a little bit better than that. Multi-positional air handler accessories. If you look at the remotes, if you're not familiar with the remotes that are compatible with this, they look a lot like the AirStage remotes. So this is where all the new equipment is starting to move, is to that 2-wire remotes and no more 3-wire. We have our thermostat converters that we can hook up here. Maybe we want a IR receiver, we want a wireless remote we want to use, Wi-Fi. Everything's going to be able to adapt right to this board from here. And we have some external input and output PCBs that we can mount in here as well. Give us some more flexibility if we want to hook up maybe auxiliary heat or something under those lines. There is, if you notice here, there is no spot for a filter. So we do have an accessory. We have our filter base that'll accept a 1 or 2 inch filter. We don't want high density filters, more of the fiberglass type. So there is a model number for that as well, or part number, so. There is, if we're doing downflow applications with an electric strip heater, when we're pumping heat down, that thing's gonna get really hot. We do recommend, this is a floor base that's meant for electric heat applications, and that downflow is configuration. And mentioning electric strip heaters, we do have many different configurations. As you can see here, we have our A series, which I have in my hand, our B series, and our C series. So A with the breaker is probably going to be your most common. We'll take a look at that breaker in a little bit. We have some important instructions we want to cover on that as we go further. So this electric heater, available in different kilowatts, from 2 ton to 4 ton. Just keep in mind what our minimums and maximums are, how big of a unit we can put in there, and how we control it. Coming really soon, we will be able to do some zoning with the AirZone product. So this is something in development now, going to be released hopefully sooner than later. There's great flexibility. We can zone up to 10 individual zones. So we're doing individual ducts off of our plenum, which makes it really nice. Wired and wireless dampers, as well as remotes and or thermostats, we can call them now. So a lot of nice stuff coming hopefully soon. So basic installation practices, connection points. We're going to go through some tips here. Like I said before, multi-positional gives us a couple configurations here as far as upflow, downflow. Right? So you'll see those in the 1 and 2 positions. So horizontal left, upflow, we don't have to make any changes. Downflow and right, or horizontal right, we might have to flip out coil. So we'll look at that briefly as well. We always want to keep in front of the unit at least 24 inches of access here, just for service. If I had to pull this coil out of here, if I had to pull this blower out of here, I want to be able to pull this out and not have to hit any obstacles there. We'll look at that as well when we start hanging these things. I hate that I have to even mention this, but we never ever want to cut into the side of the cabinet to provide return air. There's probably a good probability of you going through and piercing that coil with a screw or whatever shears you're using. So all our return air is going to come from the bottom of the cabinet here. If we're going with an upflow and it's in a closet, we're going to have to build a base. Our ductwork is going to support the air handler, so we just got to make sure it is able to support it. It's a couple pounds there, it's going to sit on top of it. So again, upflow, we don't have to make any changes. If we are going to sit this in a closet and we're going to pull directly through the floor without return air, we do have to seal this up with a fireproof caulk underneath it, just so it is 100% sealed tight. Downflow installations, you'll notice here in the slide, we have to do a coil conversion. So we will provide inside the box, we have our rails. So these are going to get mounted inside the cabinet here, and then we'll be able to flip that coil and let this sit on the rails itself. So we'll look at that a little bit further. Any questions at this point, Rob?
No, nothing yet.
Nothing? Beautiful. So we're going to keep going. So downflow coil conversion. Horizontal left, we do not need the coil conversion, so we are configured right out of the box, makes it real easy. If we're going to go horizontal right, we got to convert this now. We're going to make sure that pan's on the bottom. So again, we use those rails that are provided for us. Like we said on the horizontal, upflow and downflow, we want to have that service access. We want to have that same access if we're going to hang this horizontal left or right. So when we are hanging this, we've got to make sure we are using the proper support methods. We don't want to have it so we have threaded rod, coming across or whatever chains you're using. This way we're interfering, we're pulling this coil or blower out. We don't want to have that sag that's going to start to dent the cabinet as well. So these are just great techniques to learn. If we are in an unconditioned space, just keep in mind that this cabinet itself could sweat, so we might want to wrap it. We have the insulation wrap that we can, just like our other ducted models. So especially if we're going to have, we want to have that drain pan underneath it as well if we're going to catch any condensation, but we'll go over that in a second. So our connection points for our line sets are all going to be flare. So just like you've been familiar with all mini splits and all Halcyon products, we do have flare connections here, make it very easy to connect to. The coil itself is coming through with 5 to 10 psi of nitrogen. So this is nice. If we pull these flare nuts off to go make our connections and we don't hear that pressure relieve itself, there's a good chance this could be compromised. So we just want to make sure we keep these on until we're ready to make those connection points. We don't want to get any moisture to get inside there and make our job a little bit more difficult when we start to pressure test in a vacuum. When we do take these flare nuts off, we always want to use a wrench right behind the flare nut. We want to use a backup wrench so we are not doing damage to the copper tube you see here. Any damage there, obviously, we're going to have to make some major repairs. You might not be able to see up top here, we do have what we call duct flanges that are provided with the unit. These will be bent, as you can see in the slide here. We're going to bend these, secure them to the top of the unit, and then we'll have an attachment method for our supply ducts. So pretty simple to use, just like every other multi-positional air handler. It's nothing too difficult to do. Just follow the installation instructions and make sure we're designing our ductwork properly and adapting everything to most standards. Again, the return air is not here. We don't provide it. We do have an accessory. You saw that earlier. If we are designing against maybe a 4-inch media filter, an electronic filter, we always want to have, we'll want to size this a little bit larger than we normally would so we can overcome the pressure drop on the system. So it's one of the biggest things to keep in mind, especially with using those 4-inch media filters themselves. Drain connections, just like your traditional systems, we have our primary, then we're going to have our auxiliary drain connections for our vertical and our horizontal. So whatever one we are not using, we want to use the provided plugs to seal them up. They're just going to thread inside here. Your adapters, just keep in mind, this is a plastic drain pan. So when we are putting in our adapter to our PVC, I always like, number one, a little bit of Teflon. Use your hands. I never put a wrench on it. The last thing you want to do is crack that pan on a brand new installation. We'll be going to the supply house to go get a new drain pan, and that's not going to look good. Got some questions, Rob?
Yes, we got a question here. So what do we do if we are looking at a 3.5 ton application?
Well, BTUs, right? We're going to do our load calc. If we come up with something at 3.5, well, we can go with a 4 ton. We could go. One of the nice things about, and we're going to talk about it as we wrap up, is the function codes of our system, where we do have a function code for maybe plus or minus 10% airflow, right? So we will be able to adjust maybe a 4 ton and bring the airflow down to match that 3.5 ton capacity. So that's all going to come down to sizing and function codes. If you have an application like that, we'll be more than happy to help you set that up. Anything else?
No, that's it.
Beautiful. Good questions. Good questions. So condensate drain, again, we always want to have a minimum 1/8 inch pitch out of the house. We want to get that as far away so we don't have any damage coming in. Just want to keep in mind your traps that you're using, 3-inch minimum. Easy traps are really nice. They do come with a float. So if you're familiar with that, I mentioned before, we'll look at the connection points, but we could hook that float directly into our unit. Makes connection a lot easier. We don't want to go into a sealed plumbing system. If we're doing the drainage, we want to get that outside or to an open floor drain. It's just going to make things a lot better in the future. You're not going to get the running water in the customer's pipes. I've heard many times in the field before. So we do have, like I mentioned, we have this auxiliary drain port. So it's always good practice to use an auxiliary. In some, you can see in the picture to the right here, they're using a float switch in place of using that auxiliary drain out. So that float switch would get wired into the unit. we had maybe a clog in our main drain, it's going to shut the system down. I always like having a dual lines and maybe using, if we have, maybe a secondary pan underneath the unit to catch any drainage, then we use that, maybe a water alarm, and go to those connections so we can shut it down. But I always liked having 2 drains. So looking here, we do want to use, and just keep in mind, this is a normally closed position switch that we have to have, whether it's an alarm or a float switch. We have these 2 connection points up here, 1 and 2. If you can see them on the slide. So 1 and 2 is going to be our drain connections. That's an auxiliary input there. So it's going to come out 12 volts as that switch opens up. It's going to shut down the system so we don't produce any more condensate. God forbid we had a leak in the system, or maybe a clog in the system, I should say. So out of the box from the factory, we do come configured for that function code number 46. You can see the black diamond there. That's 00, so that's operation stop. So if we did have an alarm, the system's just going to shut down, which is what we want. So again, I've said it a couple of times, the auxiliary overflow pan, definitely good practice. We want to catch any condensation that might come off in a cabinet if we're not insulated and we are in a unconditioned space like an attic that's 140 degrees. Line sets themselves, which really nice about all 4 of the models here, it's the same line set size. So we go 3/8, 5/8 throughout the whole product line. Makes it a lot simpler when ordering those line sets. So we like easy, right? So flare connections, we do provide you with some insulation here. Once we are done, and we know we don't want to put these on until we properly leak check the system and make sure everything's sealed properly. But we do provide the adhesive. You might have remembered these if you've done ARUs before, our slim duct, right? So we can put this on. This is going to cover our flare connections. We do provide, I believe it's a handful of zip ties as well. So once that is on there, we can kind of seal it up and make sure there's no leakage, no drips coming from those flare nuts whatsoever, which is really nice. And because our expansion valve, if you notice, where it would have been is now in our outdoor unit, that means that we have to insulate both of our line sets, right? So if our EAV or our expansion valve is in that outdoor unit, we just want to make sure there's no drips again from flare connections, no slices, so we insulate all the way around. And please, we never want to use existing. If we're replacing a traditional system that might have, maybe we're taking out an old system, we never want to use that line set that was there, even if we flush it, even if it's the right size. We always want to use new line set. Flaring techniques, have a quality flaring tool. Orbital is better, makes a nice quality flare. Sharp cutting blade, a good deburrer. We want to make sure that pipe's pointed down so those burrs are not going in the pipe and clogging up our dual flow or biflow strainers, expansion valves, or anything else we might have. So flares, we like flares as long as we do them right. The only thing we want to put on the surface of that flare is refrigerant oil. We don't need the nylog, we don't need the leak lock, we don't need anything like that. Those are all lubricants that are going to help you crack the nut if you're not using a torque wrench, right? And speaking of torque wrench, here's our values. Get familiar with them. This is not a Fujitsu, chart. This is a standard flare chart. So you'll find this in the tools that you're getting. If you have flare tools, we have some like the one Hillmore you see in the slide there. This all comes pre-programmed into that torque wrench. Makes it a lot easier when you guys are out there. So this is piping limitations, but I don't like the limitations because as you see, we can go up to 230 feet. That's like putting the outdoor unit at your neighbor's house 3 houses down, 230 feet. So, it's really not a limitation for us. You can see here the 2430, 2-ton and our 2.5, pre-charge 66 feet. On the 3648, we can go 98 feet pre-charge. And then our minimums go across the board 16 feet, which is really nice. We share that. We also share the same height difference. We can go 98 feet high, which is almost a 10-story building. So a lot of flexibility there. But you can see that max pipe length is 164 on the smaller and 230 on the 36 and 48. Just because we say we can go 230 feet doesn't mean that's a good thing. So we got to keep in mind, before we looked at the performance at -5 degrees and we said it was about 28,000, I think it was 440 BTUs. We want to keep in mind, the further we go out, we might lose some BTUs the further we go. So I put this together the other day, and this comes out of our design and technical manual. We have our capacity compensation for heights and distances. So, right here we can see, and I'll blow this up a little bit there. you're gonna see our height. So we said we can go 98 feet, right? So that's above or below our compressor. And we can go out to about 230 feet. So 229 here is close enough. So as an example, if we went 16 feet high and 98 feet total line set length, which is a lot of line set, you'll see there's a number there of 0.995. We're going to take that and multiply it by our 28,440 BTUs at that design temperature. We said -5 degrees maybe. If it's that cold where you are, I don't want to be there. But 0.995 times 28,440, we're going to lose 140 BTUs, not much, right? But if we went to that 230 that we say you can go, we're going to come up with a different number there. We're going to lose almost 5,000 BTUs. So if we're talking, like Rob, the question, what was it, 3.5 ton unit, right?
Yeah.
So if I needed that 3.5 ton and I put the 3 in, and it might have covered me for most days, and I was able to boost some airflow there, you know, maybe we went that 230 feet and now we just lost 5,000 BTUs, and it takes us out of that, you know, BTU range that that system can provide. So we just got to keep in mind, heights are great. We just got to keep in mind what we're going to lose if we're going to go the 98 feet, or if we're going to go the 230 feet or 164 on the smaller guys. So it's a good chart. It is design and technical. You can see in the yellow found in that manual. Portal and Zendesk is where you're going to find that. So once we get to the leak testing, we get our connections made. We want to put through some nitrogen, and I got some question marks there. So if you guys can please put in the chat, let us know what are you guys pressure testing at today? How many PSI are you putting of nitrogen into that system? So let me know what they come up with, if anybody answers here. So we're going to use some soap and bubbles once we got the nitrogen in there. Make sure we got those systems sealed tight. Right? Once we know it's sealed and everything's good, we can release the nitrogen. We're going to put that vacuum pump on. We're going to start to evacuate that system down below 500 microns. Right? We want to get it down to maybe 300. Make sure it sits for a little while. And we want to make sure we're not rising up above that 500. If we have moisture in the system, we might have a nice humid day. It's a little difficult to get below that 500. We might have to go into a triple evac or something like that. So we want to follow industry practices from the ACCA or the RSES vacuum guidelines. So, and of course, our manufacturer's guidelines. Anything?
We got one answer, 400 PSI.
It's not a good answer at all. So 400 PSI, you know, those are, you know, that's high pressure, but if we can operate at 450 PSI, if we look at the label on the side of the machine, it's going to tell us what our design pressure could be. So in heating mode, we might operate at 425. So if we're only pressure testing at 400 and we have a leak, you're never going to see it. So we need to pressure test at least 600. Oh, I gave up the question mark. So there's that 600 PSI is what we gave you the answers, and we still came up with a 400. So 600 PSI is where we need to be. We just want to make sure.
500 we had.
All right, so we feel a little bit better with the 500. We need to look at the machine and know what we're going to run at, and then we can pressure test above that. If we went beyond our pre-charge amount, which you can see here, 66 feet on the 2.5 ton, 98 feet we said on the 3 and 4 ton. If we go above that, and we can go up to that 164, 230. We do have to add some additional refrigerant all across the board. All 4 models, we're looking at 0.43 ounces per foot. So not a lot of refrigerant there. If we went an extra 10 feet, you're talking 4.3 ounces. So we just got to, you know, critical charge as always, and make sure we're weighing in properly. The electrical part of it, I think that's where it gets a little bit more exciting compared to a traditional system. Is we're powering from the outdoor, like we said earlier. So we have our traditional 14 gauge, 3-wire and a ground. We got our remote cable, 16 to 22 gauge. It's a 2-wire twisted shielded wire. So those connections are going to look something like this. We got our connection points up in the top here, our Y1, Y2. So that's going to be our remote terminals. Our power wire, 3-wire plus ground. Might need a disconnect switch depending on where you're installing this and your local code. And then we got our power wires coming in, our 2-wire plus ground. Should have a breaker or disconnect in line there as well. The breakers for the systems, again, the smaller units, 2 ton and 2.5 ton, we're going to have a 30 amp breaker. 3648, we're going to have a 40 amp breaker. So keep in mind. So here we're going to look at a little exploded view, a little bit close up here. We got it on my right as well. So you're going to see these connection points, as I pointed out earlier. We're going to have our Y1, Y2s for our connection cables, our outputs, and so on. We're also going to find here our 1, 2, 3. and our ground up at the top of the cabinet. So our wires are going to come in from the side. So all those connection points are very close. Then we have our control transformer located right here, main control board. And then, if, like I said before, we could add additional control boards and stuff like that, which we've looked at. Here we go. We're not going to go too deep into that. So another view of that Y1, Y2. Getting a little close in there. Perfect. So you can see a little bit. One thing I want to note too is before we hit that power button, we cycle on the system. We want to turn on that battery in a remote control. Right, so there's a battery inside there with that switch off from the factory. If we do all our settings and we lose power, we're going to lose all our settings, controls, maybe a schedule that the homeowner had set up. So just get used to turning that switch on. The only other switch we have inside here that you want to get familiar with is a bank of 3 dip switches here, right? So it says set 1. So you see number 3 there. That's going to come in the on position. We're always going to assume that you're going to hook up that electric strip heater into the top of the cabinet here. So we did have electric heat at the end of every heat cycle when we hit set point. We're going to run that fan for another minute just to make sure we cool down the cabinet and we're not overheating those elements. Right? So if I don't have that electric strip in here, what I want to do is, again, before we power up the system, we want to turn that number 3 dip switch off. This is going to stop maybe some complaints, maybe some cold air blowing on the homeowner if we didn't have, the electric strips in there. So it's not a bad thing to do. You can leave it on. You might not get a complaint. If you just want to avoid it altogether, we can turn that dip switch off as needed. So once we make these final connections, and here's a nice the heater installation guide. So you're going to see all the model numbers. We said before we had an A, B, and C series. This is a part number list of all of them. The one thing we wanted to note here, looking at our breaker. If you have an A series, which is probably the most I guess is probably the one you're going to see the most, I should say. You got your breaker, you got your heating element there. We always want to disconnect these wires that come with it, right? So very similar to what you're going to get, almost identical to a traditional system electric heater kit. We do not need these. So these need to be removed and not hooked up to the system. Our incoming power from our panel is going to come into the back side of it. So just keep in mind, we want to remove these wires, red and black. We do have a bulletin that shows full installation, and you'll see that many, many times. And as we get to the end here, so function settings are where we're going to make our final adjustments, right? So function settings can make a good installation even better. So you guys might be familiar with 1 through, let's say, 9 here, or pretty, we've had these all along our product line. 10 through 21 are some new for the multi-positional. We've had some of these for the RGLX, our mid-static units, and maybe even our new ASUGs, our new high efficiency systems. So with this board that comes with it, we can kind of turn this, if, like I said earlier, we want to do some auxiliary heating. Maybe I don't want to use the electric strips up here. I want to use a hydrocoil. I want to use some other auxiliary heat source. We don't need separate controls. Our remote control that comes with the system can do everything we need it to do. Just by adjusting a couple function codes here, we can adapt to pretty much everything we need to. And then as we wrap up here, we just want to go through our startup checklist, make sure everything's connected properly. We have no leaks. Drains, it's another big one with air handlers. We want to make sure our drains are flowing and we have no leaks. Again, at the end, we want to make sure our homeowner knows 100% how this thing's supposed to operate, what's it going to sound like, stuff like that. So we want to make sure we explain that properly. So as we wrap up here, we're going to go to questions in a few seconds here, but just keep in mind anything that we do currently, everything that we're doing today is always going to be on our HVAC Insiders website. So you get a screenshot there. So everything's recorded there, as well as the training schedule. So we have one more. Tomorrow we're going to wrap up our webinar Wednesdays. We're already 3 down now on our Fujitsu training series. So we got some more coming up there. So that's where you're going to go to sign up. And Rob, you get any other questions?
I'm assuming that you're going to go over this when we talk about accessories, but we had one question regarding third-party thermostats.
Right. Currently, if we're going to use a third-party thermostat, we're going to use a TTRX, which is our thermostat converter. So that's something that we would hook up to the system here and go to the remote terminals, and then we can hook up anybody's third-party thermostat. We just want to know that anytime we're doing that, we're going to lose some efficiency here in the system. If we're using somebody's just because of an app, because they want to be able to control it from, Wi-Fi or whatever the case is, we do have Wi-Fi. So in a lot of the cases that I've been, confronted with, if I gave them Wi-Fi, Fujitsu Wi-Fi, they're more than happy with doing something like that. Anything else you want to review?
Yes, real quick, we have a question regarding this system being incorporated into a multi-zone system.
Coming soon.
Yes.
It's as far as we're going to go with that. Coming soon. Sooner than later, hopefully. What else we get?
That is it for now.
All right. Well, guys, I want to thank you. You said you got my email there. You got Rob Clemens' email. Any other questions you want to shoot at us, please take a screenshot of that. Send them our way. Other than that, we will see you guys next time. Thank you very much.